Want to come on a journey with me into the world of Google Cloud and deploying a Flask application on compute instances and Cloud SQL? Well, let's do it. Let's go. Hey, what's up, everybody? It's Ned Bellabance, Ned1313 on Twitter, and welcome to Terraform Tuesday. Today's topic is all about deploying a Flask application on some compute instances in Google Cloud and hooking it into Cloud SQL. That's what we're going to cover. And of course, we're going to do the deployment with Terraform. Now, before we get into that, I have two quick things that I want to mention. Number one, if you are interested in sponsoring a Terraform Tuesday, if you're a vendor with a Terraform adjacent product and you're like, yo, I want people to know about my awesome product, talk to me, hit me up on Twitter. It's Ned1313. I've got some sponsorship packages available and they're very reasonable. The other thing I want to mention is my Terraform certification guide. It has been updated with all the version 1.0 goodness that is in Terraform, and it starts at $15. So check out the link down in the description if you're looking to get the Terraform Certified Associate certification. With that out of the way, let's talk about deploying applications on Google Cloud. All right, in a previous video, I showed how you can get started with Google Cloud. So we went through that whole process. And then I had a video after that that was getting us ready to use GitHub Actions to deploy things on Google Cloud with Terraform. Those are the first two videos. This video is going to be about actually getting an application deployed. And then the video after this is going to be putting it all together using our hosted runners on Google Cloud to deploy applications to Google Cloud using the baked-in authentication for those runners. So that's going to be pretty cool. That will be the next video. This one's all about actually getting your application deployed. So let's dive into what was involved in setting all this up. So the application is a Flask application. If you're not familiar with Flask, it is a framework for Python that helps you build websites, basically. It's not something I was super familiar with. I'm not like a huge Python person, but I was assured by many people that it was relatively simple to set up. They were mostly right. I watched a Pluralsight video by, and I'm going to try to get this name right, Reinhard John Ecker on Pluralsight. I'll include a link down in the description if you want to check it out. And it's basically a getting started with Flask, deploying your first application and understanding how it works. Knowing Python would be helpful, but I don't know a ton of Python, and I still found the course really helpful. If you happen to be watching this week when I publish this video, it is currently Pluralsight Free Week, which means you can watch that course or any other course on Pluralsight for free. So, like maybe check that out. I don't know. So I wrote this app from scratch. I thought it would be nice to have just a sample application that I can use for stuff. It's a basic poll app. So you can create a new poll with up to 4 answers, and then you can have people go to that poll and vote on the result, vote on it, and you can see the results tabulated live. Like I said, it's actually a very simple application. The backend for it is using a MySQL database backend. So the components that we need to set up our infrastructure in Google Cloud are some compute for it to run on and some Cloud SQL for the database to reside on. So that's kind of what we're going to create, but let's go over the actual configuration that's being deployed in a little more detail. First, I just want to describe the infrastructure we're going to deploy, and then we'll take a look at the Terraform code. Let's start with the different resources that we're going to create. We're going to need some instances, some compute engine instances to run our Flask application. And I'm going to use an instance group to do that, because you can just load an instance template into an instance group, and every time it needs to spawn another instance, it will use that template. So we're going to use those two constructs for our compute. And we'll have a startup script that loads that Flask application and any other stuff that it needs. Now, it's going to need to talk to a database, so we're going to have to create a database. So we're going to do that. We're going to use Cloud SQL, and we're going to use the MySQL 5.7 version of Cloud SQL for that component of it. And within that instance, we're going to create a database called VOTR, voter, because that's the name of my application, because E's are for suckers. Anyway, okay, so we are going to have those two components. The next component we're going to have is secrets. we're going to need the application to know about the name of the database and the connection data for that database. And that stuff, well, especially the username and password, is going to be pretty sensitive. So we're going to put that in a secret and then extract that information when the app loads on our compute instances. So we need all that. And then lastly, because we're going to have more than one instance, we're going to need a load balancer of some kind, and more on that in a moment. So that is our architecture at a high level. And the code, the application code, is hosted on GitHub. Again, link down in the description and also in the source for Terraform Tuesdays if you want to take a look at the application itself. Okay, so those are all the building blocks. Let's go over to the code and check out how we built it. Okay, here we are in Visual Studio Code, and I've got the project folder open. It's 2021-10-12 GCP Voter. You can always find these files at the Terraform Tuesday repository on my GitHub account. The link should be up right now. It's also down in the description. So if you're looking for these files, if you want to follow along, awesome, go for it. That's where you can find them. Okay, let's go over what's in here. We've got two folders, which is the project creation, which is a module that I've written before that allows you to dynamically create a Google project and then host the resources in that project. So I'm not going to go into detail about that. That was in the previous video. If you need to click through, go for it on that. The other folder is the scripts. We have a startup script that the instance template is referencing. So we have that. And then we've got our main, our Terraform, and our variables. Let's jump right into main because that's the important part here. Okay, and let's jump up to the top. There we go. Okay, so first we have to create a project for our resources to live in. So we're going to use the project creation module to do that. And then we can reference that project ID for the rest of the resources in our configuration. Then we're going to create a service account. The service account is used by the instances so that they have permission to access the secrets that's going to be in the secrets manager. Okay, so we need that service account. We're going to create that. Scrolling down a little bit more, we're going to set up our Cloud SQL instance, and we're going to host that privately. So it's going to get a private IP address on the VPC that we're creating, so the instances can talk to it directly. It doesn't need a public endpoint. And then we can restrict traffic to that database to only stuff that's on the same VPC. That makes sense. So we're getting this private IP address to do that. And then we're creating that private VPC connection for our database, referencing a network that we're going to create a little further down. Then we create our Cloud SQL instance. Nothing real exciting here. Scrolling down a little bit, I do have Cloud SQL IAM authentication enabled, but I'm not really using it yet. That's a future potential improvement that I might want to make for this. And we also have the IP configuration here that connects it to the private network so that our compute instances can talk to it. Okay, scrolling down a little bit more, we create our actual database, and then we have to set the root password of the database. Now, the way that we do that is we have Terraform generate a random password for us. And then this is specific to the way the MySQL works on Cloud SQL. You have to create a SQL user, call it root, say it's built in, and then you can set the password for that user. So you have to do that. It's not baked into the instance when you create the instance. Even though I think there is a password field in there, MySQL doesn't use it. Okay. Now, I also created a SQL user for the compute instances, but it's not actually used yet. That's a future improvement that I want to make. And I gave that particular service account, which I created earlier for the instances, I'm giving it cloudsql.client and cloudsql.instance user rights. But like I said, it's not using those yet. Future improvement. Okay. Next, we're going to create a VPC for the application. It's going to be a single network with a single subnet in it. We have to configure a router and a NAT like you normally would. And then we have to configure some firewall rules to allow HTTP traffic and give it the target tag of allow HTTP. That's something we can leverage by our web instances so that they'll allow port 80 traffic to get through to them. But it's actually going to go through a load balancer. So we'll see that in a moment. Okay, now we get into our wonderful world of secrets. We are going to create a secret in Secret Manager. And we're going to label it VOTR SQL Connect. That's going to be important later. And our secret ID is VOTR-2. token. Okay, now that we know that, we're going to create a version of our secret in Secrets Manager. So before we just created a nebulous secret, now we're actually putting some data into that secret as a version. And for that, we are setting some secret data that has to be in JSON. So we're doing DB user, DB pass, the database name, and the database host, which will be that private IP address and port 3306. That's the connection information our application is going to look for. And it's going to look for that information in environment variables that correspond to the keys in this secret data. So it's going to look for DB underscore pass as an environment variable to make its connection. So we got to make sure we get these environment variables right. And then we are going to add our service account as a member that has read access to this secret so that when our compute instances spin up, they can go out and get that secret data. Okay, that's cool. Next up, we've got our GCE instance template. This is the template that's used to spin up the compute instances, and we're using a module for this because why wouldn't we? So we have this managed instance group template module that's available from Google that lets you specify a bunch of stuff. Important things in here are the network you're going to use, the machine type you're going to use, and then if we scroll down, the service account we want to associate this thing with, that's going to be important to access those secrets. And then some other information like what image you're going to use. We're using Ubuntu 18.04 in this case, so we're going to specify that information. And then there's a startup script in here. The startup script is in the scripts folder. We'll get to that in a moment. And then lastly, we've got metadata in here. And in the metadata, we're setting secret ID to the name of the secret version that we stored. And this allows our startup script to grab the name of the secret ID and then reach out and actually get that secret information. And then lastly, we have some network tags. And one of those is HTTP-server. That's going to reference a firewall rule that's created automatically by a different module. Okay, we have all of that. Before we go any further, let's get into the startup script and take a look at what's in the startup script. All right, our startup script is stored in scripts, and we'll go ahead and open that. And the whole point of this is to download our application, our Flask app, and get it running. Now, in order to do that, we're going to do a few things here. We're going to install things like Git and Python and JQ so we can do the things we need to do. We're going to fetch our source code from my GitHub repository that has the source code in it. And then we're going to set up our virtual environment for Python and install the required modules that our application uses. Next thing to do is fetch that secret information. So we are going to use a curl command against the metadata service on our compute instance. And we're going to look for an attribute, a specific attribute of secret ID. And in that secret ID attribute is the secret URI that has the data we want, the secret URI version. So we'll do that. And then we're going to break apart that secret URI and we're going to get the secret name and we're going to get the secret version out of that URI. And then we're going to use gcloud, the command line interface, to grab those secrets using the secret version and secret name. And then we're going to split those secrets up into key value pairs and load those as environment variables. So boom, there you go. That's all we need to do. We have our environment variables set. And then the last thing we're going to do is go into the directory where our application was cloned. And we're going to use Gunicorn. I don't actually know how to say that. I've never said it out loud. Gunicorn. We're going to use that to start up our application and expose it publicly on port 80. So that's the whole startup script. That's how our application gets running. Is this the absolute best way to do it? Probably not, but I'm sure in the comments you'll tell me what the way I should have done this is. Okay, so that's the startup script. One more thing to go, which is the load balancer, and then we'll get to actually deploying this bad boy. One of the fun things that I discovered in this process is that Google Cloud doesn't have an actual load balancer. It has constructs that fit together to become a load balancer. But if you go in the Terraform documentation and you actually look for a load balancer, you're going to come up empty because there is no load balancer construct as far as Terraform is concerned. What does exist is a module. So if we go back to main and we scroll down to adding a load balancer, we're going to use the module lb-http that Google has created for us. And that's going to create a whole bunch of resources. We can use target tags so that it will appropriately tag the firewall rules to allow the traffic to the networks and subnetworks that we're going to use. And then we describe in here the backend that we want to point it at, which would be our compute instances, our managed instance group. And we're going to create a health check for that backend. And for us, it's just port 80, request path is /. And then scrolling down, what groups do you actually want to target with this backend service? And we'll just feed it our managed instance group. And that's it. That's the entire config. Like I said, there's no actual load balancer, but when you deploy it, it creates a bunch of resources. When you look in the web UI, the cloud console, it says it's a load balancer, but it's not quite. So if you want to dig into that module and find out more, absolutely go for it. Let's go ahead and get this sucker deployed. All right, we're going to get this sucker deployed. And if you're following along, go into the README. You're going to need to set 2 environment variables. Well, first you're going to need to log into Google Cloud at the command line and set 2 environment variables, and then run this gcloud auth application-default login so Terraform can use your credentials. And you'll need credentials that have permissions to assign billing and all that kind of jazz. So make sure you've got some elevated permissions that you're running in. Now, I've already done all of this, so I'm going to go ahead and open up the terminal down below, and we'll go ahead and run standard Terraform practice. We'll do a Terraform init. That's going to grab all the modules I've referenced, including the project creation module. And once it's done downloading all of those components, we'll skip the Terraform plan and we'll just go straight into a Terraform apply. All right, so there we go. It's installing all the provider plugins. Excellent. And an interesting thing about Google is there's a Google and a Google beta provider, and it has to load both of them because of some of the stuff that we're using. Okay, so now that we're done that, we'll go ahead and run Terraform apply, and we're going to use the auto approve flag here. So it creates all the resources for us. And now that's going to go ahead and kick off a plan. So it's going to tell us what it's going to create. And then once that plan is complete, it will actually go through the process of deploying the infrastructure. Now, one thing I want to note about this, and it's something that probably needs some further improvement or something you could deal with in automation land. It creates the project and enables the APIs for the project. Sometimes those APIs don't enable right away, which means when it goes to create a resource, the API is not yet enabled. And so the Terraform provisioning fails. It errors out. What can you do about that? Well, in this context, we can just rerun the Terraform apply and hopefully all the APIs are enabled at that point. If that doesn't work, well, that wouldn't work in an automation scenario. So a future improvement, if you're automating this, is to run the project creation component first, wait a certain amount of time, maybe 2 minutes, and then kick off the remainder of the creation of the resources. And you can even have it as 2 separate configurations and have a pause that only happens if you've added new APIs or created a new project, and skips the pause if nothing has changed about the project's properties. That's just some personal thoughts of mine. Let's get back to the deployment and see how things are going. This can take a little while, so I might jump ahead to where it's finished. Oh, and as I predicted, there's an error. If we scroll up to see what the actual error is, it's going to say Compute Engine API has not been used in this project yet. And that means that it's still trying to enable that API. And so even the data source that it's trying to use to get availability zones fails because the API hasn't been enabled yet. So we're going to have to wait a couple seconds and then rerun Terraform apply auto approve, which I've done. And now all of those APIs should be successfully enabled, and we can move forward in the deployment process. All right, our deployment has successfully completed. Let's go ahead and connect to the front end for our application and see if it loads. So we'll go over to the Google Cloud Console. You could also expose this information with the proper output in the Terraform configuration. But let's go over to the Cloud Console, and we're going to go and take a look at network services, and you'll see load balancing is in here. But remember, there's no actual load balancer per se. There is this URL map, which is part of a number of different resources that compose the load balancing, as it were. You can see there's a front end here, and some host and path rules. And then there's backend services, which need a health check associated with them. And those backend services are associated with an instance group. So that's all like the components that make up a load balancer. The thing that we care about here is this IP and port. This is the front end. And we could put a DNS entry in front of this, but let's go ahead and just grab this. And we'll open up a new tab and we'll go to it. And here's the polls application, the voter application. And if you want, right now there's no polls, right? It initialized the database because it was a new instance of the database. And it has no polls in the table yet. So let's go ahead and add a new poll. And let's do something contentious, right? Is pizza a taco? Interesting question. And now I'm going to go ahead and make one answer, yes. Another one, hell yes, no. And we'll go with maybe for the last one. Okay, and then click create. We've created our poll. Now we can go to the poll and we can vote as many times as we want for the different polls. So we can see the application has loaded and is working. So our deployment was successful. Hooray! Okay, to summarize what we did in this demonstration, we stood up the infrastructure to run a Flask app that's using a Cloud SQL backend, all in Google Cloud, and we tried using Secrets Manager and some other best practices. Now, there's definitely some room for improvement, and maybe this is a challenge for you. One thing I'd like to improve is the use of modules in my Terraform configuration. I could probably add specific modules for creating the database instance component instead of doing that in the main.tf. And the networking probably could do that from a module as well. So if you want to collapse all that stuff into modules, hey, go for it. That would be pretty awesome. The other thing, and this is more an issue with Flask and the database authentication, I'd rather use the service account to access the database and make updates via the application, but that would require rewriting some components of the application itself. And it would also mean that you need some way to grant that user proper rights on the database to make those reads and writes from the database. And so that would have to be part of the Terraform workflow. And I'm not sure exactly how that would work. So that might be some homework for you if you're curious. In the next video, we are going to dive into how we can deploy this whole kit and caboodle using GitHub Actions, and then we can use different branching strategies to test out different environments as our application grows and changes. All right, that is going to do it for me for today, this Terraform Tuesday video. If you are interested in knowing more about using Flask, definitely check out that course I mentioned. It was really easy to get through and very informative. It's only 2 hours long, and I tend to watch at 1.5 speed, so definitely go for that. And like I said, it is free week on Pluralsight right now. It is October the 12th, so this week is free. So if you take the course this week, you don't have to pay for it. The other thing I want to say is, hey, if you don't mind subscribing, I really appreciate that. And it helps the channel and helps the visibility. So click that subscribe button. And you know what? If you want to talk to me, if you have comments, leave them down below or reach out to me on Twitter. It's Ned1313. Till next time, stay healthy, stay safe out there. Bye for now. You know, I was really hoping to use my Sony a5100 to film this episode. And I took a look at the first run of video, and it had all this weird like squiggles and artifacts in it. So I don't know what's going on with that. Looks like I'm gonna have to do some troubleshooting or maybe just get a different camera. I don't know. If you have suggestions, let me know. All right, bye.